Artificial intelligence has sharply reduced the cost of producing answers, forecasts, and strategies. What it has not reduced is the difficulty of deciding what should be optimized, what trade-offs matter, and when a solution is actually better. As prediction becomes cheaper, judgment quietly becomes the bottleneck. This video explores what judgment really is, why it is often mistaken for intelligence or effort, and how AI is starting to make this distinction visible. For decades, many organizations implicitly assumed that good judgment was widespread. Intelligence, however, was rigorously tested, credentials were filtered, and effort was rewarded. Judgment was assumed to follow automatically. However, when a machine can instantly generate plausible answers, summaries, or strategies, it becomes much harder to hide vague thinking behind busyness or complex terminology. While AI is far from perfect and still has many flaws, for many problems it is largely smart enough when given the right instructions, tools, and context. However, even for such problems, people often still struggle to implement AI efficiently. An uncomfortable realization for many may be that they are not struggling with AI because it is new or has flaws, but because their goals, constraints, or reasoning were never very clear to begin with. In that sense, AI behaves less like a disruptor and more like a diagnostic mirror. Have you ever prompted a model and gotten an answer that exactly matches your question, but you realize that it is not what you were looking for? At such a moment, it becomes clear that the limitation is not always the system's ability to respond, but sometimes the clarity of the question being asked. Choosing what to ask is, at its core, a matter of judgment. But what is judgment? Judgment is the act of defining what better means. It's the process of establishing preferences, values, and trade-offs that transform a prediction into a decision. While a model can predict the likelihood of outcomes, only human or human-defined judgment can say which outcomes we desire, which risks are acceptable, and what we are actually trying to achieve. AI has perhaps revealed that much of what we called judgment in the past was actually just effortful prediction. People often don't make value-laden decisions. Instead, they estimate outcomes based on experience and then default to established norms or incentives. Decision theory formalizes this neatly. A decision combines data, prediction, judgment, action, and outcomes. AI, while far from perfect and still needing supervision, excels at prediction, estimating missing information or future states given context. However, when organizations automate prediction without clarifying judgment, they surface contradictions in incentives, metrics, and strategy. Many failed AI projects may collapse not due to poor models, but due to ill-defined objectives, unclear circumstances, ambiguous success criteria, or unresolved value conflicts. This also explains a paradox. Access to AI tools is largely equal, yet outcomes diverge dramatically. Two people can use the same system and receive vastly different value. An explanation might be clarity. Someone who can explain what they want, why it matters, and what constraints apply can often get useful results. Conversely, someone who, for example, struggles to make judgment calls about what context is relevant might only get noise. Put differently, struggling to get value from AI may reveal unclear thinking that existed long before the tool arrived. In practice, prompts function as an interface between human cognition and machine inference. Generic prompts tend to produce statistically average outputs. High-quality results emerge when users supply structured context, constraints, intermediate steps, and evaluative criteria. This is why experienced practitioners rely on decomposition, iteration, and verification rather than single-shot prompting. The machine scales reasoning, but only after the human has framed the problem precisely. At this point, some might object that judgment is already solved by simply stating a goal. If the objective is make money or be happy, it can appear that nothing more needs to be defined, and that AI can figure out the rest. This is where the illusion lies. Such goals are placeholders, not judgments. Make money does not specify time horizons, acceptable risk, ethical constraints, opportunity cost, unique circumstances, or trade-offs with health, relationships, or meaning. Be happy is even less precise, as it conflates, in other words, combines short-term pleasure with long-term fulfillment, stability, or purpose. When goals remain this abstract, AI does not remove the need for judgment, it amplifies the consequences of its absence. The system may optimize for whatever interpretation is easiest to formalize, often in ways that technically satisfy the goal while quietly undermining what the person actually values. In other words, vague goals outsource judgment by accident, not by design, and the results can feel efficient while subtly drifting off course. From a systems perspective, modern AI functions primarily as a prediction engine. It reduces the cost of generating probabilistic outputs across domains, text, code, images, forecasts, and classifications. What it does not supply is the utility function. Decisions still require humans to define goals, constraints, trade-offs, and values. This distinction matters because if prediction becomes cheap, the remaining bottleneck is judgment, which involves problem framing, prioritization, and interpretation under uncertainty. It is important to acknowledge that for some problems, a default answer can be good enough. When the stakes are low, the environment is stable, and the task is well understood, a broadly reasonable solution can perform perfectly well. The difficulty arises when this intuition is carried over to competitive domains. Goals such as make more money, grow the business, or advance my career exist in adversarial or crowded environments where many others have access to the same tools and similar information. In these contexts, the default answer is not neutral, it is average, and in a competitive environment, that's a problem. AI makes competent, conventional strategies cheaper and more accessible, which raises the baseline for everyone. As a result, advantage does not come from having an answer, but from having a better framed answer, one shaped by stronger constraints, longer time horizons, and a clearer sense of what others are overlooking. Here, judgment is not optional, it is the differentiator that determines whether optimization merely keeps pace or genuinely creates leverage. Furthermore, it is worth recognizing that judgment operates in layers, and not all layers must be exercised by the same person. Consider a writer using an AI agent specifically designed for novelists. The model provider sets the first judgment layer, such as basic ethical policies. An expert author could embed a second judgment layer, generic writing knowledge such as structure, common strategies, or tips. Finally, the writer provides the third judgment layer, personal experience, themes, and emotional truth. In this stack, some layers of judgment are effectively outsourced, not to AI itself, but to other humans whose expertise has been embedded into the system. A person does not necessarily need to focus on every form of judgment, but they must possess the judgment relevant to their specific layer to retain a competitive advantage. Outsourcing some layers of judgment should not be confused with outsourcing thinking entirely. This layered model of judgment may contribute to the explanation of why AI can be enormously empowering for some, while remaining opaque to others. Those who understand which layer they occupy and what judgment is required of them at that layer can delegate other tasks without losing their creativity. That is, as long as the system used was built with these layers in mind. A focus on augmentation rather than replacement is key. Higher layers should remain flexible, largely unopinionated, and hopefully transparent. This raises an uncomfortable but important question for individuals. If AI exposes weak judgment, what should actually be done about it? The unglamorous answer is reading, learning, and thinking more carefully than what feels efficient in the short term. Outsourcing thinking entirely is not a high-value AI use. From a skills perspective, communicating with AI effectively resembles communicating with other technical systems. Code, mathematics, diagrams, and formal abstractions are not elitist barriers, they are compression tools. Science does not use precise terminology to sound intelligent, but to reduce ambiguity. The same applies to AI. The more complex the problem, the more costly it becomes to explain without shared abstractions. Attempting to describe or understand advanced concepts without the appropriate language is cognitively demanding for both the human and the model. To close off, we will only run out of work if we run out of problems. Energy systems, healthcare, infrastructure, education, automations, and efficiency improvements, among others, all remain unsolved at scale. AI does not remove the need for human contribution. It raises the bar on clarity, responsibility, and judgment. When problems become challenging, we need tools that enable experimentation, integration, and iteration without collapsing under complexity. Such tools become force multipliers for judgment rather than substitutes for it.